Hello, everyone, and welcome to another episode of Solving Advent of Code in Rust and try to learn Rust in between. I am Roberto, and we have
Luciano?
and
And Eugene, hello.
thank you everyone for following along. If you never did Advent of Code is a challenge that is published around Christmas Eve, around Christmas period every year. We are working toward the last year's one. There are 24 challenges, and that you can find them on adventofcode.com. We are publishing all our code in a GitHub repository, this one. And we have a YouTube channel where we publish all the recording. You can find the link in the description of the Twitch channel. Last time we were in exercise 22 and we did part 1. Now we are doing part 2.
Yep.
Okay.
And
There's the code.
yep. So should we start with a little recap of part one, maybe? I think that's a
Yes,
good idea.
let's do it.
Because not everybody might know. So in short, the first exercise was a game called Crab Combat. That's that's what they decided it's called. It's essentially a card game where the players get dealt cards. I think they're between 1 and 10. I'm not sure if there's anything larger. And the two players have two cards of equal length to start with, like the two examples here, where player 1 has 9, 2, 6, 3, 1, player 2 has 5, 8, blah, 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 blah. The idea is that at every round, each player plays the first card in their deck, and whichever card is largest wins the round, and the player who had the larger card gets both of the cards. The goal is to acquire all the cards in the game. That's when a player wins. So they do have a little example here. We did this last time using vecdq. That's how we defined the deck as a struct, which has cards as a vecdq, and we basically pushed and popped as the game progressed, and we found a winner, and I think we were returning, the sum of all the cards of the winner. That was the requirement. Now, part two is called recursive crab combat, which is a great name, but it adds a bit of. Oh no, it's called recursive combat only. Apologies, no crabs. The no crab for you. This one adds a bit of a spin on the game, which is there's now recursion, which basically means that you start a new game with the remaining cards if there are some there are some limits for it which are defined here. If both players have at least as many cards as the value of the card they just drew, the winner is determined by running a game of recursive combat, which basically means you take the deck that each player has and you start a new game with those particular cards. There's also a recursion breaking thing, not thing, but maybe system, let's say, which which basically acts as follows. We need to store the state of the decks that the players had throughout each of the rounds, and if the deck currently being played is the same as one that happened in the past, player 1 wins. This is basically what this thing is about. So before either player deals a card, if there was a previous round in this game, so this is per game, including the recursive games will have their own stack of previously played hands. In the same order in the same player's decks, the game instantly ends in a win for player 1. Previous rounds from other games are not considered. So this is essentially the only this particular game non-recursively. I think there was a third rule somewhere.
I think there was a difference in how the cards are collected into the decks.
Yeah, that was it.
The winner card go there, and then the loser card go on the back of the winner card. Even if they are lower, because it can be that they are lower and not
depending on the
higher.
recursive game.
Yeah, exactly.
Yeah, correctly. Oh yeah, if there is a recursive game, the winner is defined by the recursive game as opposed to the cards that will have been dealt. So there's that to be kept in mind as well. And what Roberto just said, that the cards go in by the winning card first, regardless of value.
Winner, loser.
Exactly.
So I suppose we can visualize that as if there are the conditions for a recursion. It's like you are taking a snapshot of the current game, so the decks and the cards on the table. You start on the side the recursive game, and then whoever is winning that recursive game, you come back and the winner collects the two cards and you continue with the previous game, right?
Exactly, yeah. I don't think there was anything else here. There were examples, but I don't know if it's worth going through them, as in it'll take us probably the next half an hour.
No, I think we
Yeah.
can just describe it in code. Probably.
One last thing that I'd want to go over is the actual, okay, what is the winning player's score? So this is basically, again, getting the count of all the cards that the winning player has.
Yeah, I think there was like you reverse the order of the cards and then you multiply the value of the current card per the
It says
index.
here.
By the position,
yeah. You're right.
Card value multiply the card position plus 1, because obviously multiplied by 0 is not good.
Yeah, the winning player's score is calculated from the cards they have in their original deck using the same rules as regular combat.
So we already have written that.
Yeah,
the
we
code
have
is
that.
already-
There was, look, it's mapping, it's multiplying by the index. We're reversing, enumerating, mapping, and summing them. So this is technically here already. We can maybe extract that as a thing to make things nicer, as a function or some form of abstraction. For now, though, we have this deck struct that we've defined last time, which derives partially Q and EQ, so we can actually check different decks. We also built a game history thing. I don't remember if we did it on the stream or not. Apologies, English is difficult. Which is a hash set of tuple of 2 decks, basically. So we can keep track of snapshots in history of how how the players' hands looked. So for now, we're starting a new history and we're inserting the initial tuple of decks. And what we have to do is the actual game. So I suppose we could use this. Sorry, we could use this. No, we couldn't use this function. This is just a start, I suppose, for a recursive. So let's maybe define the recursive. Actually, this is going to be a recursive game because it gets a new history, but it's not going to be run on each.
Part 1?
Call it.
What is part 1 was
Part 1
implemented.
is just below. But
It's just implemented in the part 1. You didn't make the function for that.
No, we didn't. It's just a loop, which is looping until you break it, pretty much. And the condition is one of the players is without cards. And I suppose we can use the same thing here, but we will also need to call this game recursively with decks, with a clone of the decks. Actually, let's do that maybe. Because we can copy this stuff. I know, it's great that we copy stuff, but hey.
Can I ask you maybe to make it 1 point bigger, the font?
Yeah, absolutely. I'm sorry for not doing that first time around. Is it readable or should I go more?
I think this is better. No, that's good, probably.
Yeah, for me it's fine.
If anybody watching doesn't see, doesn't read, let us know in the chat, please. And apologies if you've been running blind so far. Okay, so we have the exit conditions.
Now
which are now
P1Q
called...
and P2Q are called the deck 1 and deck 2.
Yeah, we can... Yeah, let's just call them this because it makes more sense, I think, to call them decks. Yeah, it was like player 1Q, player 2Q because they were just a VecDQ at that point. But now they are not anymore. Okay, so if either of them lost, we can break and return the winner's cards. What else do we need to do? We need to check that the current state of the decks never occurred in history, right? That's an early exit condition.
That's yes, absolutely.
So I guess if
basically we need to check in the history if it contains a tuple that has deck 1 and deck 2.
Yep. If history contains, it's not happy because
I think we
reference.
already killed number 20 in line 29. We should have cloned deck 1 and deck 2. That would
Correct.
be my expectation, but I'm not sure.
You're correct, yeah.
Why doesn't like it?
Because it's not clonable.
Oh, because it's deck, not the.
Oh, because we created
So
Deck
we're
is a
called deck
container
that
for
does
the
not.
DQ.
Okay, yeah, we need to derive clone as well.
And let's see what's happy now. Mismatch
Okay,
types.
now there I think it needs a reference in front of the tuple.
Yeah.
So an ampersand in front of the tuple.
Okay, so if it contains this,
The
this
winner
means
is
that
player 1.
Yep. Wait, because we're not.
Probably when we break here, we have to return ID if he's winning the player 1 and player 2 and the winning deck, not just the deck. Because here in this condition, we have to say always win the player 1 without considering his deck.
In this particular,
in this particular case, we have to say player 1 wins.
Yeah, pretty much. We do have these things below where we're pushing, but we're also getting the cards, so I think we should be getting the cards as well, right? Actually, we do need to pop the cards out. Actually, no. These need to be done.
You have to do that before popping out the cards.
Yeah, the history check needs to happen there. Well, we need to pop them out anyway. Why is it
I believe the history check could be even the first thing in this function. The first thing in the loop, I mean.
Why if they are in the history, you have to pop them out?
You need to pop the first card from both of the players and give them and put them at the back. So essentially, this is going to be deck 1. Sorry, deck 1, deck 2, and we can get deck 1 cards, push back, B1 card, and I think I need to call it again. I don't think it's happy with me doing this only once. P2 card, right? In this order, because player 1 won, if that makes sense.
And we also have to exit from the full game function.
No. Yeah, you're right.
Yeah.
We need to break
exit from the full game function. But you can't return in there?
Wait.
You can return. Yeah.
Why do we want? Do you mean this? This doesn't end the game itself. It's just the round, as far as I understand.
That condition ended the game. Read me again.
Does it?
Sorry.
I think I misunderstood.
Sorry. I remember wrongly, probably, but let's check.
So, where is it? Before either player. If there was a previous round in this game that had exactly the same cards,
the game
ends with a win. Okay, so this means we break with deck 1, and that's it.
You can return.
Also, right? Because the return is with also a U size that is probably the winner deck.
No, so the way we did it before was with this break, which is how you return from a loop.
Yeah, but we can just return here.
Yeah, because here we want to do it recursive, right? So whenever we are in this condition, we finish the entire round of recursion and pop up one level, right?
Yes, but we need to break here, and then outside of here, we need to return winner, basically.
Yeah, but we also have to return if it was player 1 or player 2, the winner. And we don't have that information outside of the loop if you break with just the deck.
Do we care which one it was outside?
Yeah, because when we call the game again in recursion, we have to choose based on which one won what to do next. So we need to know which one won, and you can't use the length of the decks because Doesn't depend.
Because you have a snapshot of the previous deck, not the one
So
from
this
the
means
nested game.
this also needs.
Also because when you find something in the history, it's always player one that is winning.
Correct.
Whatever
Okay.
is his deck is the winner.
Okay, so what do we want to return then?
Now, you sides and deck is fine. If you sides is the winner, one or two, right?
I think that was the idea.
Was that the idea? Okay.
Yes. I don't remember why we wanted to return the deck, though.
But the deck is to make the computation at the end.
Yeah.
Oh, yeah, that's why.
So
That's why.
we
And the
return
winner,
one.
we need a winner because we need a winner to do if on the recursive.
So return one and deck one, because that's basically it.
Exactly. Yeah.
Yeah, in this special case that is written in the rules.
But I'm not sure that we need to do this pop there in that particular case.
I think that is only happening in subcalls, so it's more
You're
or less.
right. P1 doesn't need. It's just the second one that needs to be added to deck one. To deck one. Essentially, you need to add the cards that player 2 will have played to player 1, right? Or do you not?
I'm not even sure that this is needed, but leave it there. I don't think it's changing anything.
Before either player deals.
Yeah, but we are not doing this here. We are doing that in the loop above.
So you're right, actually, this might...
I would remove both entirely and put this condition at the very top of the loop.
Sure, okay, that's correct.
I think this is, to me, the first base condition of the recursion.
Okay. That sounds fair enough.
On 37 and 40 now, can't we return again just 2 and deck 2 and 1 and deck 1?
Yeah, we can. I don't remember why we were doing this the original time.
Because you were not in a side function, you were inside part 1, and so you needed the winner to... Because now we have to write a function called part 2 at one point that will call game and get the winner and do the math.
Cool. Yeah, we can return this directly right now.
By the way, there is an interesting suggestion from Tommaso to, instead of using using a U sides with 1 and 2, we could create an enum like player 1 and player 2, which definitely more readable.
It is gonna clarify the intent.
Improvement when tested green.
Exactly. Let's improve it after we make it work.
I just wanted to mention it because it makes more sense in context now.
I agree. It's a very good idea.
We pop from the front the cards, and then we have to check if we have to call the recursion. What were the rules? If
I don't even know.
Have enough cards in their
if
deck.
Both players have at least as many cards remaining in their deck as the value of the card they just drew. The winner of the round is going to be this. So essentially, if player 1 card, P1 card is larger equal than, smaller equal than deck 1 length.
Okay. And the same for player 2.
Yeah. So go ahead, Luciano.
You probably need to say P1 card as U sides and P2 card as U sides.
Correct. Sorry. You're right. Is it not happy? Oh, yeah, dot cards.
Oh, yeah.
Because it's now a struct. It's not just a type alias anymore.
Okay. Oh, in this case, we have to call
a new game, basically.
Yeah. But with all the cards, or with just the number of cards that are...
With, let's see, playing a new game of recursive combat. Oh yeah, with the cards remaining, yes.
So you ignore the ones on the table.
Yeah,
you ignore the ones on the table, yes.
Yeah. So we need to start a new game which gets the 2 decks, right?
A copy of them. Yeah, a copy of them. Cool.
Yeah. What do we do with this though?
This is returning
Winner.
the winner and the deck of the winner. We don't care about the deck of the winner, to be honest. We just care about who is the winner.
Yeah. Let's. What's the first one? The winner.
Yeah. And the commander score.
Yeah.
Equal, yeah.
So we don't care about.
Yeah, we don't care about the deck. We
Yeah.
just go. Okay, so if winner won, I suppose. Do you see a neat way? No, it doesn't matter. Essentially, if the winner was player one, then player one deck gets all the deck one. Push back, if I can type. And it's going to be player one card, because they won. And then another one for player two card. Else.
Else,
deck
because we know
two.
that else is the other way around.
Yeah, it's gonna be, but that's easy enough to do. Like so.
Okay.
Push.
And this is if we went. Why
cards.
Okay, again.
There are advantages and disadvantages to using this struct here. Having to write cards everywhere is one of the disadvantages. Okay.
Yeah, unless we create a method that does that for us. But anyway.
Yeah.
Optimization later.
Recursive game. Recursive combat game starts here.
Just a second, I'm gonna pop a few comments. So one is how to differentiate line 34 from 40, which in fairness they look the same, so maybe they can be unified. The other one is 34 imply player one wins, 40 doesn't. I'm not sure I understand.
Why doesn't? If deck choose run out of card, player one won.
Yeah.
Yeah. So I think it's a good instinct to probably merge the two.
Yeah.
But I think the condition is correct in both cases.
Yeah, but keep it separated because it's more readable and is following the rules. Then if we want to optimize, we can do that later.
Exactly. For now, I would keep them like this because this is like regular game rules. This is the added history.
Also, the variable winner in line 31 is not used anymore. So because we are always returning inside.
Oh, you're right.
Okay, so the question is, in a case, I think it's the case.
The game.
Yeah, we win the game.
The current game.
The current game. Now we have now we have to do an else of the if that we open an inline 45. That is the normal game. Why now is unhappy?
I don't know because I removed this declaration there.
You can't just loop. No.
Deck one borrow of moved value. Where is it moved?
It should tell you where it is moved.
27.
Value moved in 33.
33. Yeah.
Oh, you need to do contains with clone.
You're right.
Okay, because cool.
We probably removed that clone, I guess.
I think so for some reason. Not sure why. No. Cannot borrow is mutable.
But we have to mutate it, right?
But it's because it's not deck one mute deck one and mute deck two.
You need to do references or no?
No, I'm getting clones here.
Okay.
Why is it saying that this isn't used? Because we're using because we're not actually pushing to it. Jesus. So these are the returns. And we must also
just after the check we have to push in to insert.
So wait a
not
second.
The insert line. I remember that we added the insert line.
No, we don't. So
okay. But no, we can do that after we check it. It's already around that before popping from the card, I think.
Before popping? Wait.
Before popping.
No.
Before the pop front. Or
Before
after.
Wait, let's read the condition again. Before they deal a card.
Before.
If there was a previous.
Before
So
we check if it is in. If it is in, we return. Done. If it's not in, we put it in.
Yeah.
Yeah, so let's put it in line 35 and 36 between them.
Just as an else. Because if it doesn't contain it, right?
Well,
I don't
if
think
it
you need
contains
the
you,
else.
you return, but in any case, you don't reach that line if it goes inside.
Insert.
Now we have
actually,
to clone like crazy. But yeah,
I'm
that
just
we already...
going to
29.
copy
We
this.
did that in 29.
Did we?
Yeah, move that line.
but
Move that line inside the loop.
You're right.
In line 35.
35. Yeah.
Done. I was remembering that we wrote it, but I was not seeing where.
Yeah, we did now. Okay, so we're inserting it on each loop. If it wasn't before, we have the winner here.
Fine, we have to do the else of the if that we open in line 46.
Yeah, so if they don't start a recursive game,
we go with the normal rules.
Yeah, which we have here.
Yeah, if P1 card greater than, you have to rename the variables because we changed the...
We will, no bother. P. That should be it. Okay.
Each card is the same. Okay. Now we have to call this from part 2. Do we have a function called
Was there? There should be one. Yeah, which just returns the number. So we need to parse the input same as we did in part 1, because I know there was a neat...
Yeah, we implemented the from string, right?
Yep, exactly. I just wanted to copy that, make my life easier. Let winner equals game of P1Q, P2Q, right?
You wrote PQ1.
Great. That's what I wanted.
And also keep in mind the game returns a tuple. Well, winner is not really the winner right now, but it's the whole tuple. So you might want to...
Winner and deck.
Winning deck, yeah, something like that.
But we don't care about the winner here, so you can put an underline there.
Actually,
correct.
When we call it from here, we can... It's funny because when we call it from here, we just care about the deck. When we call it from recursion, we just care about the winner.
Yep. So we need to winning deck and all of the stuff that we were doing on the previous run.
Perfect. And then you need to input. I think you have an underscore.
Line 104, the input variable as an underscore.
Oh, Jesus. Right, you are correct.
Now, why doesn't it like sum there?
The trait.
Do you get a reference where?
I'm not sure. Oh, the winning deck, I think, is returned as a reference.
No, there it looks like a deck. Like otherwise, you will see in the type annotation.
Correct.
Deck.
We return the deck. Yeah.
So what is the pro?
Sum of U34.
Sum.
U34, U32 to U sides. But why this didn't happen before?
Because we return a U sides. We have to return a U32 in line 104.
Oh, yeah, in the function definition. That's why.
In line 104, yes. Return a U32.
Correct.
We did the same mistake even in the previous episode.
And
it took us a while to realize.
No, you can remove the mutable from there. No, just
and I can just pass. Fine. Yeah. Okay. I can remove the mutable from there. You're right.
This is something that in Rust still I don't get. The variable in his outer scope is not mutable, but you pass that to a function as mutable, so it becomes mutable when you pass it to a function.
I think the mutability, you can imagine it as being part of the type itself. I think that's the... maybe they don't use... they use something like covariance, I think, but...
If in my scope, if in the scope, I want it immutable. Then I pass it to a function, and the function mutate it because I'm passing as mutable. Is hiding in a certain sense that variable got mutated. Because if you do a const variable in JavaScript, for example, even if you pass that around, it's still a const.
With the exception of objects and arrays,
object.
but
Object are
and arrays.
yeah, exactly.
okay.
They are immutable no matter what.
Sorry.
But
I
yeah,
don't
I
know
get what you
if
mean.
I agree with that, because it feels pretty more explicit to me in Rust, where you need to say in this context, because even in the function signature, you need to define what is coming in as mutable. So it's kind of
it's just
explicit.
That in the function code is mutable, but it comes from a context where it's not mutable, and you say, okay,
but you're giving it up when you're passing it on. So you're not passing a reference to it.
But you can still pass a mutable reference, but okay, that's
you can, but then you have to define it on the other end, on the receiving end, as a mutable reference. Whereas here, you're just receiving it and you're receiving ownership over it.
Yeah, I think if this was a reference, it will be more explicit. Like you will need to create the reference also as mutable.
That's
here is because you're giving it ownership.
Then and giving the variable to the function, do what you want.
That's it. In JavaScript, they are passed by reference. Objects and arrays are passed by reference anyway, unless you explicitly clone them when you pass them to a function call. So Luciano's right, it is more explicit here.
Yeah, Tommaso, I think, shares our feeling. Because you move the ownership of the variable to another function, so you don't need to know if the inner function changes the variable or not.
Exactly.
Yeah. If we are going to not give to the function the ownership, that's another discussion.
Yeah, exactly.
It would be different. But well, okay,
now,
let's try to see if the test is working or not.
Let's see. Oh, because we still left. Sorry, I left the unimplemented. I think.
But why
somewhere.
we reached it?
Because it was at the very bottom of this function, where it was below all the code we wrote. Running one test.
Yeah, there was just a warning, by the way.
Okay.
Oh shit! It's frick. What did I do?
Okay, we have an infinite loop.
No, I think it passed.
It did pass?
No,
Hang
that's
on.
part one.
How do I get rid of all of this crap?
I think we have an infinite loop, but let's try again.
Let's try one single run. I also think there's an infinite loop.
Okay, let's go hunting.
Yeah, it should have finished a long time ago. Okay.
So we have 3 exit conditions.
Yep. We return the first player as a winner if the deck was contained in the past, and we return their deck. Else, if player 1 finished their cards, player 2 wins, or if player 2 finished their cards, player 1 wins.
And that is easy. Now I have adapted the hash map of decks. We are cloning a lot and putting stuff in, and we are using the contains. Do we have to derive something different? We have to make sure that a tuple of deck is matched to another tuple of deck. Can we write a test? Can we write a test? Can we write a test?
We can, but I'm quite sure it works. But let's write a test because that's the best way to be sure.
Correct.
Okay.
So.
Because I think we are deriving EQ, and EQ is basically implementing equality checks.
Okay.
So that should do what we want, but let's double check.
Okay.
Right.
Basically, the test I was thinking about is we create 2 decks with 1 card just to be fast.
Yep. New.
Only if we did create.
I don't
we
think
can't use
the
curly bracket. No.
Oh, we can do from string, right?
Well, from string, fine, perfect.
But then you need to define it exactly as the input.
Wait, isn't it from No, we don't, because we give it we split it by split ones by new line.
So
I
deck
think
was
it just I can do that, man. All it has to start with is like player 1 and player 2. That's it.
Okay.
Is it actually from string? No, it's parse. No.
But
Is the
deck
string
is what
parse
deck
and wrap?
the Q or was our own type? I don't remember how we
Deck
defined deck. Was a
is
type
our own
alias
type.
or
No, it's our own type which contains a vecdq inside it. And from string, it skips the first line, and then it maps over everything else.
Okay.
so the easiest thing we can do is to create a vecdq.
Okay.
I was liking the Eugen idea of having a string
Okay.
parse and wrap.
So we can probably do this thing, right? With player 1
/n
/n, if I can type,
and a number.
then 1.
Okay, fair enough. And you need to unwrap.
Because it's, sorry. Okay.
Because that might fail.
We need 2 of them. Wait. Deck
Yeah, we
2,
need 2 decks.
player 2, why not? And then we
And
need
you
to
can
assert...
put number 5. Put number 5 in player 2 or another number. Just to have a little bit of difference.
Now,
Just a
when
check.
we insert reference to the clone, copy the same line that we used to insert, so we are testing the same stuff.
This pushback.
No, the scroll up.
To part 2, sorry, yeah.
Yes, 35, line 35.
History, okay, yeah, you're right. For the history to insert, you're correct.
We insert we also have to declare the okay.
Yeah,
The
it's
history
fine.
variable.
History equals, did I define it as a type?
History,
or game history, new?
Yeah, we define it as an alias.
And it needs to be mutable as well, because we insert into it. Okay.
Okay.
And then history, actually
Contains.
assert EQ, right?
Contains.
History contains
How
a
do
tuple
we
of...
do the contains? Do we clone and we
We clone.
reference? And we reference also.
I think we put a reference here.
Yeah.
But let me just be super certain. Contains, actually, how about this, including the ending bracket. Assert equals...
There is an
this.
assert true, Luciano.
Yep, just assert.
Assert, like this.
Mm-hmm.
Okay, let's run it.
Semicolon, not semicolon.
Sure,
I
semicolon.
don't think it makes any difference there, but
Yeah, it passed.
So I think Tommaso has an interesting suggestion, but that might be an optimization. When we insert in an hash map or an hash set, it returns true or false depending on whether the item was really inserted because it was new or was not inserted because it was there before. So we could probably use that in our logic to simplify things a little bit.
Yeah, because you can check the round before.
Okay, well, let's go
Or
back to see.
at least this is what I'm guessing, that this was the suggestion from the question. Tommaso, if you had anything else in mind, please write it in the chat.
Okay, so that is not the problem.
No.
Another thing we could do, I suppose, is to define like a display for our game somehow, or decks.
To print the decks
and
out?
print them, to print like the rounds, and see if we spot anything obvious.
Okay, so dbg history with a clone.
Or you can pass a reference to DBG, like ampersand history.
Okay. Sounds better. Why is it not happy?
Oh, because history does not implement debug, but we can easily derive it. Just give the debug to deck.
Wait, where is... There it is.
Guys, we have a bug.
We do.
Yeah. Go in the readme.
Yes.
Go
Where are we
on
looking?
part 2.
Yes.
I don't know where this is said in the text, but go in the example for part 2 when it say game 2. If you scroll.
Game 2. Wait.
One day.
Game 2. Okay.
There. Okay. It take. Scroll. No. Stop.
Yeah.
Stop.
Yeah.
Sorry. Line 217 and 218. 4 and 3.
Yeah.
Then they go in the next round. Do you see in line 225 that player 2 deck is only 3 elements, not all
So
the
it's-
rest? Is long as
Yeah.
as long as that number. So it's not
Okay.
what's left. Is what's left for. So we have to change when we do the sub call. It's not cloning. We have to slice.
Yeah. Yep.
Yeah.
Okay.
Is a clone of the deck, but only for P1 card for P1 and of P2 card for P2.
Yeah, but how do you... Does it know how to do this?
We have to
You
take
do-
on
Cards, sorry. As slices.
we have to take the first N element from there.
Yeah.
Pikachu.
Pikachu. As
Uh,
slices.
How do you
Split
take
off.
from the queue the first N element?
I don't actually know. And it also wants a deck.
Yeah, but you
Not
can do
a
deck,
vector.
curly brackets.
Yeah, you're right.
What
Cards,
happens if you
yes.
do cards dot pick? Is there a method called pick?
There isn't, no.
With Chui,
Okay.
peak. Peak. I don't
like
know. I'm
this?
asking.
No.
No.
Let's see. Vec DQ. Get first
N.
N.
Yeah.
Yep. This is something I have no idea about.
Or this, I think, is the. But then we need to collect, right?
Okay,
If
we have to prepare 2 variables for the new decks.
Mm.
Because doing that online is already too much chaining of
Yeah.
not this, not that, not this other.
New deck.
New deck 1, new deck 2. Perfect.
Sorry, my typing sucks. Sorry. Okay, so this is gonna be deck 1 cards. Dot iter dot
take. Oh my god.
I should call iter. And takes the
It's
first.
Not, is keep or take? What is the difference?
No. Take is the one.
Okay.
So this is this star or usize, yes. Okay, as usize. Okay, and this is going to be the same, but for deck 2.
Yeah, but like Luciano was saying, we have to convert it to. Do we have to collect it into a
Vec the queue, right?
fact the queue and then pass
because
it
it's
to
iterators. Jesus, sorry.
You can probably call. No, you cannot call it deck.
U8 or
U8 was it? I don't remember. Deck is a vec the queue of card.
Which
card.
is an alias for U8, but yeah.
Yeah, just to
I
keep
think
it in mind.
a nicer thing we could keep it in mind for later is that if we implement from iterator, then we can easily call collect directly into a deck.
Yeah.
But yeah, things to do for later.
Exactly.
Now I have a question. Okay.
Vec the queue U8 cannot be built over an iterator. Oh, because they're references.
Because they are references.
Map.
Do into into
Into iter.
iter, but then you might have to clone. If you do dot cloned at the end before collect.
It seems happy enough with into iter.
Okay.
Okay, so this is gonna have to be. Actually, this isn't even new.
Yeah, the only difference with into iter is that I think you are consuming deck 1 and deck 2. Instead, with cloned, you are not.
But we don't have to consume them.
No, that's not how you do a new deck, right? I don't remember how you make a new.
With that should be correct.
Assign it to something.
Or
Probably
maybe
is complaining
just
about it.
let's pass it
You can
here.
pass it there, yes.
Okay, it is
That
happy with
should
this.
be it. Now I'm not sure that. Yeah, I think that into iter doesn't work because it's complaining line 36 and 39.
Yeah, because we don't need to destroy that because with into iter we are destroying it and we must not.
So keep just iter and before collect put dot cloned.
Yep, I gotcha.
Cloning like crazy, but
yeah, it's not ideal.
Now, is this compiling?
It should be.
So. Seems all.
Let's see if it's maybe even passing. Who knows? No, it's not. It's an infinite loop still.
So let me understand, because I'm not sure I understood what was the bug initially. That when we see that the two players are playing cards, the value of each card is
so you need
less than the remaining cards, right?
No. This player drew a 4, and this player drew a 3. This player had 4 cards, which is fine. This player also had 4 cards, but
the
sub-game started with 4 and 3 cards, whereas we would have just passed the entire hand.
Oh, so you only keep the number of cards corresponding to the number you played.
Exactly.
I think it's written somewhere in the README. Let's try to read it again.
Don't know. So before, if there was a previous no, as in regular combat,
if both players have at least as many cards as the deck, the value of the card they win, the winner of the round
playing a new game.
Okay.
See below. During a round of recursive combat, if both players have at least as many cards in their own decks as the recursive, the winner of the round is determined by recursing into a sub-game.
Okay, to play sub-game recursive, each player create a new deck, creating a copy of the next cards in their deck. The quantity of card copied is equal to the number of card draw. So, okay, we are doing that.
We are doing that.
We are doing that.
The number of cards they drew to trigger, okay.
Okay, so
no cards are removed.
We fixed this, but we are still in a loop. Why?
Yeah.
Another thing we could do is to implement that debug thing, and then we use as an input the example we have there. So we create a test with the same input as in this example.
So this thing...
And then we should read the same sequence of events.
Fair. Let's do that. So new file. Example.
Or, we shouldn't read the same sequence of events, but it should be more obvious where we are diverging from.
Fair. So this is player 1. Another line, and this is player 2. And these each need to be like this.
And without comma.
Is it
without?
It is without, correct. Okay. So let's do... How do you do fancy finding? Can I put a \n there as well? Sorry.
I just do select and command D.
That's fine.
On my way to
place /n. That. And now comma replace with nothing. There. Years of using Vim have taught me regex. Cool. So we have another input. So we can do another function, right? Function test simpler input. Okay, so
You need to add the macro annotation hashtag test.
correct. Apologies. What the and I need to
Copy all of that.
it's gonna be example
Yep.
And what
part
is the
2
output
of
of the
input.
example?
I don't think we need to assert.
Well, we can assert it. We have it.
Oh yeah, we will have it there, right, at the end?
It should be 7291.
291.
Okay, perfect.
Wonderful.
Let's use that.
This is probably also gonna fail, right?
No, this is okay.
No, this is okay.
Interesting. So what did we do wrong there?
Beautiful.
Okay. Run again test part 2 just for.
Do you think it's just taking so freaking long? Because this is
Maybe
I have no idea.
let's wait a little bit at this point.
Yeah, let's wait a little bit. Just
sure.
talking
Okay.
about
I don't.
what's the weather? I don't know.
The weather. I don't know, man. It's dark outside.
The weather is dark.
Yeah, I'm sure there is weather, but I can't see it.
No, it's taking way
Yeah,
too
no,
much.
this has died. This has definitely died.
So let's go back to the code. For the simple example is working, obviously. Let's go back to our code and see if there is some.
I'm curious if all of this all of this stuff is actually correct. So we're actually returning the winner, right? When the cards are empty, and we're returning that correctly. Player 1 is no cards, means player 2 has 1. Player 2 has no cards, which means player 1 has 1. Next, we're popping these from the correct decks. We're checking
that the take is giving us the right deck, right? Can we just
check the take thing?
Yeah.
But where are
Can
we
we
doing
assert that the length of new deck is equal to P1 card?
Oh yeah, you can put an assert equal anywhere. Doesn't have to be a test.
EQ, new deck. Oh, sorry.
New deck one element must be P1 card.
P1 card.
Plus
view size.
Plus some casting, yeah.
Yeah. Jesus, sorry. I'm sorry, I'm really bad at typing today.
And the same for deck 2 with card 2, with P2 card, sorry.
Yeah. I think it works, but let's just check.
Yeah, I'm thinking what can be, so I'm just saying probably stuff that are stupid.
Nope, it's not failing on that.
Yeah, we'll panic if the assert doesn't pass.
Yep. Hopefully that killed it.
Oh, it's not that one.
No, we can leave the asserts in for now, because in case we mess up in any way.
It's killing nobody to have an assert.
So if the winner is 1, we're pushing the winning card 1 and the losing card 2 into deck 1. If the winner is 2, we are pushing 2 and 1.
Can you print something that tell us that we are getting into the if?
Yeah, that's I think what Tommaso was suggesting.
Line 45. On line 46. No, in line 46. Just to see if we are getting in this branch.
Okay.
You can do a DBG of something. I don't know.
Is this okay?
Yeah, I guess, yeah.
Sorry.
I mean, anything would work.
To recursive game, yeah. Close enough. Let's see if it prints that. Yes.
Okay. So we are getting a little bit too much into recursive.
It's highly recursive. So let's see what happens here. If that happens, so let's check the entry condition for these things, right?
What is upsetting me is that the subcase is working.
Yeah. So if both players have at least as many cards as the value of the card they just drew. At least as many. So we're doing this check correctly.
I think so.
The winner of the round, not the game. So we're doing
Yeah.
this correctly as well. At least one player must not have enough cards left in their deck to recurse. Is that done with an and? Yes, it is an and, because both of them have to do this.
Yeah, if you want
Mhm.
if you want to put some more bracket to be round bracket to be sure that we are
No,
doing,
no, that's
It's
okay.
fine.
I
It's
think
correct.
priority is fine.
Okay. We can debug the card, although it's just going to keep outputting it, so that kind of worries me a bit. But why the frick not? After history, dbg, history, or history, or
Yeah, I suppose
history.
the history will keep growing, right?
Yeah.
And then whenever we are recursing, we should see an empty one.
Yeah.
Unless you want to loop get the decks out, but I think
But they will be part of the history anyway, right?
let's see the I'm gonna stop it at some point. Okay, cool. Now let's see the patterns. Yes.
Let's try.
Oh no, this is the entire history though.
Yeah, that's the problem, and it's not even gonna be in order.
No. No, okay, let's not look at the history.
Maybe what we could do is print the length of the history.
Yeah, that's not a bad idea at all. Len, and then I don't need a reference to it, right?
No.
This isn't it. This is the test. Those are some serious numbers. 608, 602, 601. Oh, it is growing, yeah. Just continually growing. Is it just one history? No. It reached 586 in this one. And it started at 72? Oh yeah, 72 cards, okay. No, 72 games.
No, 72 will be. No,
Ah,
maybe you are not seeing
I think I'm not
previous
seeing the...
console. Yeah,
The very start.
yeah, you don't have
Here,
enough buffer
let's...
there.
But I do in my terminal. Let me share my terminal instead.
I have to say that is quite the second part, in my opinion, is quite slow. So
Yeah. Okay,
and
you can...
we just try to leave it running another terminal for a while.
Yeah, Tommaso was also suggesting we could build a production release of the test, which I never remember how to do it.
Okay.
That should be
no.
much faster. Let me
Sorry.
put your stream there.
Yep, I'm in a... what you call it? I'm in an actual terminal.
Make it bigger at some point
Command
later.
plus. Yeah, there we go. It's
Exercise
bigger
22.
now. Okay, cargo test. Let's see.
But cargo test is gonna hide the output. There is something
there a
like
flag?
no capture, I think.
Yeah, but
Cargo.
Like this? No, I can run it with minus help, I guess, and it should tell me.
So it's minus space minus no capture.
Like
without
this.
dash.
Without the dash, okay.
Yeah.
Okay, and now we should be able to see a lot more of it. Oh, these are sub-games. 10, 11, 12. 10, 11, 12, blah, 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 crap growing. This one is a 207 after a 25. 201. It's actually going through them.
But
by the way, this is how we try the part 2 in release mode.
Hang on.
And you can probably still add the no capture if you're curious to see.
Okay, I will. Do you want to run that, or do you want to look at this output for a little while?
Okay, understood.
You can maybe try another terminal and we run that while we look at the...
Sure, that's actually a good idea. Sorry, I forget that you can do all sorts of smart stuff on machines. Oh,
Go
because
in the
this
right
also.
folder.
I have to set stuff up on this machine. I'm sorry.
Oh yeah, don't do the capture thing here because it's gonna be slower. Just do this, yeah.
Okay, so let's go. Oh, and let me zoom into this one as well a couple times just so we can read it.
It's
compiling
taking
it
longer
there.
at compiling
Yeah.
Because it's released, so it's compiling differently.
with optimizations, yeah.
There is
Okay.
a strange jump from 324 to 128.
But because it's jumping in the recursive call above, and the history in the recursive call above is different. So we are keeping history different by game. Makes sense.
Yeah, but this was a gigantic sub game.
It finished. No, it didn't.
No.
Still building.
Yeah.
It's going. Can I get to the very... this one doesn't have the... Fucking hell, man. Sorry. Let me... Where was the setting?
Which
History.
setting?
For the history. I forget I never friggin' updated this.
The
If
length
you
of
are
your
trying to
terminal.
show...
Unlimited scrollback. Thank you. That's what I wanted.
Okay.
Now let's run this again. I'll stop it. And now we should be getting some infinite scrollback action. Oh, Jesus, man. Sorry.
Yeah, but we can't tell if this is working or not from here because
No.
it's going up, down, up, down. It makes sense. So,
Yeah.
Can you check the other terminal? It looks like it's finished now.
Oh, yeah.
so it's just
Seriously?
slow.
2.17 seconds.
Wow.
That in release is a lot. Okay, so it's
So
just
it's just
slow.
very slow.
Cool. So
How unusual.
uh,
Okay, cool.
yeah.
Well, that's good. Okay.
But
Let
at
me-
least it's working.
Okay, let me share my what you call it, the code editor again.
So we had to fix the bug. We read the README in the wrong way. Fine, we fixed it, and we
It
made
happens.
it work. The
Okay,
only problem
so
is that not in release is taking forever.
let's see. I'm gonna run it here, and let's see how long it actually takes. Frick.
No, remove the debug because with the debug is
Yeah, the
taking
debug also will slow down a lot.
Yeah, the terminal is synchronously.
Cool. Well, I was in the right place. Okay, run test. I'm curious now.
Probably cloning stuff like crazy, like.
And also, I think the hash set is not the most performant thing we can do.
Probably not.
We could convert the two decks to a string.
Yeah.
Comma separated cards. Dash comma separated cards of the other deck. That is a string in an hash set, and you go with that.
Yeah, that's probably quicker.
I don't know if that's faster. Could be
don't know.
interesting to try.
It actually passed 31 seconds in non-production mode. Okay, I will commit this stuff. What did you say? Control. There we go. I will add the example and I'll leave the tests as they are.
Leave the test and leave the example. It's fine. Also
Yeah,
useful.
The suggestion is remove clone everywhere. We are definitely cloning a lot. Probably we can remove a few of them.
But well, when we check if something is in the hash set, why we are cloning to check if something is there. We are not consuming something, checking if it is in the hash set. No? Or yes?
Hang on. Let me just push.
Again, we can convert to string.
Yeah. It depends on which comparison is. I'm gonna stop sharing because I presume there's not much, or I'll leave it.
I don't know if we want to do the optimization that we were talking about, but we are already 1 hour into the streaming and the channel. What do you say?
Yeah.
No, I mean we can stop here for today, but it will be nice if we want to leave comments about things we can improve.
Yeah.
Go back to the code, Eugene.
Just
so
as a
we can-
recap, just to finish off with that.
we can
Yeah,
chat
that's
about
fair.
it.
So,
Okay. The hash set of deck pro can be not the fastest stuff.
yep, to do. This might be slower than just strings, for instance.
I don't know. We have to test it.
Yep, that's why I said might. Clone.
The insert in one step instead contains insert, like Thomas was
Oh, yeah.
suggesting. Just insert
Cool.
instead of contains insert. I don't know how much are you get. Are you? Well, you are hashing only once instead of twice.
Yep.
And also
there's
here
also-
you are cloning even just to check the
Yeah,
contains.
Yep.
exactly. So you can just insert and do the if on the insert.
Yep.
That is speeding up for sure.
Yep.
That is fine. That is fine. The creation of the new deck, we have to do it. I don't think in 51 and 52, I don't think we can
Yeah.
get. I think we can do nothing
Yeah.
about that.
We can't pass references. Well, we can't pass references to the values, but
We
we
can
need.
pass a reference. This deck only the first three cards, but then you have to
No.
push pop. No, you.
No, 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 no. We can store the values in the deck as references, but just the values, like the actual cards. But it needs to
But
be
the
a
cards
new
are
VecDQ.
U8.
Yeah, fair enough.
Is more the U8 is more than the reference to a U8.
Mhm.
Fair. Is there any other clones?
That's why making it a string. I don't know if it's faster to compare. I don't know.
No, but I don't know either. It was just an idea. Basically, if we have a way to speed up the history object somehow,
Would be useful
probably. There
to
is a
know.
profiler in Rust, for example, stupid
That's
stuff.
what I
In
was gonna
Python,
say.
you can run cprofile and it give you, okay, this line took this time, this line took this time. And so you know where are the bottleneck in that
Yeah.
way. There is something for Rust that does the same. Tell me
Probably there is, but I have no idea. It's a
with
good
like
question.
a profile statistically sampling the application and telling, oh, I was on this line 100,000 times.
I don't know if we can see that from the flame charts, but
Yeah, from a flame chart we can
Homework,
see that.
yeah. Tommaso
yeah,
says
definitely
homework and
good
he's right.
homework. Yeah.
We can see that from the flame chart, but now the flame chart is only running if you submit a PR. So we can submit a PR with one of the changes that we not now. I mean,
Even the
offline.
Comments, I suppose.
Yeah,
I can start a new branch if you wish. Yeah, let's just do that.
Yeah, but flame chart take 20 minutes to run.
Yeah, but we can look at them later, right?
Yeah.
Add to dos. That's great. That's a great pull request. Add to dos.
If you create a pull request from this, it will do benchmark, flame graph.
I think because you have an exclamation mark.
Ah, yeah, right. You are. Is this good? It is good.
How is called the other tool that we use to do Valgrind? It will do benchmark, Valgrind, and flame graph.
Jesus, this thing doesn't have. What's the branch name again?
Add the to-dos.
Fuck this, man. Sorry. I need to set stuff up. Fuck off, terminal. Jesus. Okay, we have a branch. I'll open a pull request, which you're not gonna see.
Yeah. Also, it takes time, so let's wrap up. Okay, guys.
Yeah. Yep. I need to set stuff up. Sorry, I've not used this machine much for development work, so it's not showing me things that I wanted to show me.
Okay, let's wrap up. You can find the recording on YouTube. The link is on the Twitch in the About section. If you're watching this on YouTube, we do live streaming every Monday, 5 p.m. UTC. Make sure to check the Twitch link in the YouTube description and give us a follow so that you can be notified. Feel free to leave us comments, PR, stuff like that. The repository, again, is on the banner.
Which I need to
Yeah.
Take,
with
sorry.
Yeah.
The repository
There
is
you go.
this address. Thank you. Everything is well accepted. We are trying to learn Rust. Don't expect our solution to be super clean. I have to say that now we are more clean than when we started. And think what we were doing when we started.
Sorry.
If you know better ways, let us know. Thank you for all the suggestion and the collaboration from the people in the chat. Are we going to ride somebody?
Yes, that's why I was distracted.
So let's ride.
So raid
Ride.
starts in 5 seconds.
4, 3, 2, 1.
Okay.
Raid.
See you, everyone. Bye.
Bye.